ก็เดี๋ยวคงจะเริ่มแล้วนะครับทบทวนอีกนิดนึงนะครับรีพอร์เตอร์อยู่ตรงนี้นะครับมีเวลา10นาที12นาทีจำเวลาผิดหมดแล้ว12นาทีในการนำเสนอ opponent จะนั่งตรงจุดนี้นะครับopponent ไม่ต้องใช้อะไรมากแค่พูดแล้วก็ตั้งคำถามพอถึงเวลาจริงเนี่ยอยากจะให้ดึงบอร์ดขึ้นมาแล้วก็มาคุยกันแล้วพยายามอย่ายืนบังกระดานนะเพราะว่าเราอยากเห็นเหมือนกันว่าเราเขียนอะไรไปบ้างนะครับหลังจากนั้น10นาทีเสร็จปุ๊บ opponent มีเวลา1นาทีในการสรุปว่าเห็นอะไรบ้างจากการแข่งขันและเวลาก็จะกลายเป็นของ reviewer ซึ่งมี2 option ในการใช้ก็คือ option ที่1ต่อเข้าคอมตัวเองแล้วก็พิมพ์เลยก็ได้หรือจะเขียนใส่กระดาษนะครับบอกว่าตีตารางเป็น4ช่องอะไรแล้วก็ลองคอมเมนต์ดูจุดแข็งจุดอ่อนนะครับ question ในทฤษฎีแล้วก็การทดลองของเขานะครับอยากจะเห็นบาลานซ์ระหว่าง2อันด้วยหลังจากนั้นก็คือจะยกให้กรรมการตรงนี้นะครับเราก็จะให้คะแนนการคนที่ทำหน้าที่ reporter เนี่ยคะแนนจะคูณ3เพราะฉะนั้นจะเต็ม30นะครับเป็น opponent เนี่ยคะแนนคูณ2เข้าไปก็คือเต็ม20และเป็น review เนี่ย10คะแนนรวมรอบแล้วก็คือเป็น60คะแนนนะครับ
Okay, good morning. My name is Naruto Busri from Bangkok Christian College.
Good morning. My name is Chanakan Bunwa from Chiang Mai University Demonstration School.
Good morning. My name is Watan Yu Fusang from Viparai Vidyalai School.
Good morning, everyone. Today I'm going to talk about problem number 5, levitation. Okay, my flow diagram are define keyword, use theory, explain phenomenon, and experimental and data, conclusion and summary. In problem number 5 said that a light ball, example, ping pong ball, can be supported by on an upward airstream. The airstream can be tilted, yet still support the ball, investigate the effect, and optimize the system to produce the maximum angle of tilt that results in a stable ball position. Okay, what is levitation? Levitation. In this problem, levitation is the flowing object by the airstream, like this. Okay, and theory for explanation in this phenomenon are drag force and Bernoulli equation. Drag force is equal 0.5 rho c ab square, and Bernoulli equation is p1 plus rho gh1 plus 0.5 rho v1 square equals pressure to rho g h2 plus 0.5 rho v2 square. Okay, and coefficient of drag in this phenomenon is 0.47. Okay, we can separate in two situations. In first, the tube is perpendicular with x-axis and the tube is tilted and make an angle. In first situation, the tube is perpendicular with x-axis. Velocity of airstream are equal at any point around the object, which make unturbulence from Fd equals mg, like this. And second situation, when the blow tube is tilted, we can explain by the picture below two equations as follows. In x-axis, excuse me, we have two forces to involve is buoyant force and I call buoyant force and drag force. And we separate the force in two axes is in x-axis FB cos theta equals FD sin theta, and in y-axis mg is equal FD cos theta plus FB sin theta. Parameter in this phenomenon is velocity of airstream, degree of tilt tube, density of fluid, mass of the object, mass of the air, and surface of the object. We can optimize the system by increase coefficient of drag, increase velocity, degree, density, mass of the object, and mass of the air. In my hypothesis is mass of the object may affect to maximum deviation of an angular dependent variable mass of the object. Independent variable is mass of the object, dependent variable is maximum deviation of an angular, and control variable is type of object, object shape, size of object, and air velocity. My tool in my experiment is first is blower, ping pong balls, angular meters. Okay, but I make the ping pong ball in different mass by use the water in it. Put the water in it. Okay, my experimental setup is like this picture. Okay, we have a two digital camera, an angular meter, and scale. Okay, I want to talk about my angular meter. Is my angular meter when you see when the manual direction of angular meter is we can change the angular by rotate in center of rotation and make it into different angles. Okay, it is my angular meters like this. We can change by rotate a center of rotation at this center of rotation, and I stick the scale of in angular meter. I copy this and stick on my angular meters. Okay, my experimental procedures are connect the air blower to plastic tube, turn on blower, put the ball on airstream by starting at perpendicular to x-axis, tilt the tube until the ball fall out of airstream, record the maximum deviation of an angular. Okay, and this table is relation from mass of the object and deviation of an angular. We have information and plot it into scatter between maximum deviation of an angular with compared to the y-axis. When whereas y-axis is maximum deviation of an angular and x-axis is mass of the object. And it is a relation between maximum and minimum data like this. Okay, in summary, we have a 34.9 grams have a maximum data lab is 57.4 degrees, and 6.9 grams have a minimum data is 45.8 degrees. Okay, and conclusion, I have a function to support in my experiment is like this. Okay, when we can observe when the mass is changed, the theta are changed in when the mass increase, the theta is increased. Okay, thank you for attention.
Okay. From your presentation, could you tell me that what exactly force that make the ball flows in the air?
I think from drag force.
Can you draw
In which situation?
We will start at the strength.
Okay, strange. Okay.
Okay, from this.
Excuse me, could you open up the board so that everyone can see? Not like that, just open up.
Yes, okay.
Okay, from the problem,
Okay.
they said that stable ball.
Yes.
Yes, and could you open your video?
Okay.
Okay, thank you. For you can see that the ball move up and down. So how can you define the stable?
Okay, I think the ball is not up and down in the last one because the ball is rotation in finally. Like this. Rotation in finally. And unstable. I think it's unstable.
Unstable with the
Definition?
okay, and it rotate that.
Yes, but it rotates.
Okay, and from it rotate, do you know that what makes it rotate?
I think because the velocity around the airstream isn't equals.
So you say that the velocity is not equal, that the force just did that. Why don't the ball go this way or this way? Is it equilibrium in x-axis?
Yes, equilibrium in x-axis in the finally.
Where's the force that makes it equilibrium in x-axis?
Yes, in x-axis, I think from the pressure in the left and right, the pressure in around the airstream are equals.
Equal?
Yes.
Around the airstream?
Yes, the pressure in
Equal?
I think like this. Okay, we have like this around the airstream.
Okay.
Okay, I think so. In this picture, and the force are equal around airstream.
The force are equal around the stream.
Yes.
So what?
If you okay, my picture is mistake. I'm sorry. It's equals. I think.
That means you use the Bernoulli principle to explain this?
No. In this, I think drag force was calculated in buoyant force. I call it.
Drag force?
Yes, drag force.
But
only drag force in first situation to make the.
Only drag force, but drag force you are in y-axis, but I mean in x-axis. Is it drag force?
In x-axis, I think the pressure is equal, which make the mass of the object stable in x-axis. When we observe in x-axis.
When we observe in x-axis.
When we look at.
You mean the cause of the pressure make it stable?
Yes.
No. Equilibrium in x-axis.
Yes.
So that you use the Bernoulli principle to explain?
I use I'm not calculated, but I observe.
Oh, just observe. Okay. For next questions, you say that you use the water to vary the mass of the ball,
Yes.
right?
Yes.
So, did, do you think that the water have the effects of the stable that you define from that you
Okay.
you say that
I understand. I think the water have effect, but in finally, from the clip video, the object is stable.
stable what
Stable. Although it rotates, but I think it was stable.
when you fill the water into the bowl and put it on the air stream, is it rotate?
Yes, it is rotate.
Rotate.
Yes.
Oh, okay. And for next question, sorry. Okay, and for your experiment, you have just one experiment, right?
Yes, I have just one experiment.
Okay, you think that the mass has an effect with this phenomenon?
Yes.
Could you tell me what makes you think that the mass have the effect with this phenomenon?
Okay, I think because the mass is has the mass of in we say in mathematics, I think mass is more significant because when the mass the value of the mass is so much.
So
When compared to the coefficient, compared to the when compared to the coefficient or area, it was so much.
so that how the effect could you write the free body diagram about the relation mass, drag force, and what?
In which situation? In second situation?
Oh yes,
Okay,
I think you should to explain it one and two situation. We start at
okay, and like this.
so. Do you think it's equilibrium,
Yes.
right? Here, so you say that your experiment depends on the mass, right?
Yes.
You vary the mass, so where is the force from mass?
Okay, from we calculate. Okay, and
Okay, from his presentation that he investigate this phenomenon because of the equilibriums of the force in y-axis, right? Drag force and the weight of ping pong balls. But he don't say about the equilibriums in x-axis that it had a effect very much because the ball can go this way or this way, but he didn't do it. So, and when I asked him about the mass and the effect of the mass with this phenomenon, and I tell him to write the body diagram, but he didn't
Okay, thank
write
you
about
very
the
much.
mass.
It's time's up. So
Okay,
the
thank you.
reviewer, you have 4 minutes. Okay.
Okay, I'm a reviewer. So, about the reporter, the first point is you didn't clarify the definition of the ball, also of the stable. What is your stable? And you
Okay, thank you.
didn't say it clearly. And also the theories, you just show that, okay, this is my theory, but you didn't say you didn't say how you use it. And I think you didn't optimize the experiment because the problem wants you to optimize. That means you have to like
I think I optimized in my. Oh. Okay.
you have to find the kind of the relation or kind of duration of the relevant parameters. Not just that say that okay, this mass makes the ball can be tilted at the maximum angle. Okay. For the opponent, and you have to ask about the force that carries the ball up in the air. And for this question, I'm really wonder why. And then you have asked, so I agree with you. And you asked about the definition of stable. That's a very good question for make us understand. But you didn't ask about effect of the rotation. Does the rotation like affects the stable of the ball, or why it rotate? So switch to which one? Sorry. Just push the source. Thank you. Okay. The second about this question. So at the last minute you have you wrote the free body diagram of the tilted situation, but you wrote like an airstream past the ball. Like this. All or no. Whiteboard. Like this. So I don't agree with this figure, this figure, because the air stream doesn't flow through the ball, flow past the ball like this, but like this. So the ball is not exactly in the air stream, but fall down a little bit. Okay. Thank you.
Thank you very much.
Okay, I want to ask all of you guys first, the reporter first. When stay first, it's not done yet. The reporter, you show the video clip.
Yes.
Yeah, when the airstream goes straight up.
Yes.
Did you notice any rotation of the ping pong ball from your video?
Okay, I noticed.
So, can you answer whether or not that rotation affect the stability of the ball?
But I think it not affect because when
That's all right. The opponent is that rotation effect has any effect on the stability of the ball?
Yes, it has effect.
Okay. So the reviewer.
Yes, I think so.
Okay, anyone want to follow up?
I want to ask the opponent. You keep asking the reporter whether the stabilization in the horizontal axis of the ball has anything to do with Bernoulli equation. What if I ask the same question to you? What would be your answer? The stabilization in the x-axis. You explain. You asked him if he could explain with Bernoulli equation. If I ask you, can you explain the stabilization using Bernoulli equation?
Yes, I will explain by Bernoulli equation, but I will notice about the Bernoulli limitation to explain, because the Bernoulli has a limitation.
What is limitation?
Of one is the steadily the fluid must steady flow and can I don't know how to say beep at, and number 3 is number 4 the airs will be in the streamline and
Okay, that's good enough.
Continue from Ajahn
Okay.
Pornrat. So you two said the rotation effect. So how does it affect? Maybe answer in 1 or 2 sentence.
effects of
Rotation.
with this phenomenon. Okay, I think the rotation will have the effect with about the, I don't know, is this what effect when it rotates, it could be this way or this way. I'm not sure how they call it. What effect?
Okay, thank you. So, what can you?
I think the rotation makes the ball more stable.
Do you ask the reviewer first? Do you think his experimental setup has any drawbacks?
Sorry.
Should he improve anything on his experimental setup in this case? Well, we all talk about theory, so I just want to see if you notice any experimental setup that is not good. Is there any? Yes or no?
Yes,
Okay.
I think.
What is it?
And maybe the scale of the scale that he stick on
Okay.
the
The
bass.
scale is not good. What about you?
I don't agree with his experiment setup because his angler is just approximates the angler, and the scale on the board is just so. But I think he should just use these two for approximate the angle and
It's okay.
use the software to find the angle.
Okay ครับ Thank you very much all three of you. Thank you. Okay. So next.